Hey everyone, and welcome to a fresh exploration of the periodic table, where we bring the elements to life. I am Abigail from Mentivia, and in this video, we're going to take a dynamic look at this essential tool. We'll move beyond the static chart to truly visualize how elements behave and why they're arranged the way they are. Get ready to see the periodic table come alive through animations of electron configurations and visual representations of periodic trends. The periodic table is a masterpiece of organization. It arranges elements by increasing atomic number, which is the number of protons in an atom's nucleus. Elements are further grouped into vertical columns, known as groups, based on similar chemical properties, and horizontal rows, called periods, which indicate the number of electron shells. At the heart of an element's behavior lies its electron configuration. These configurations describe how electrons are distributed in the atomic orbitals, dictating an element's chemical reactivity and bonding patterns. Understanding electron configurations is crucial for predicting how elements will interact. Imagine electrons as tiny particles orbiting a nucleus in specific energy levels or shells. As we move across a period on the periodic table, electrons are added to the same outermost shell. When we move down a group, a new electron shell is added. These outermost electrons, called valence electrons, are the ones involved in chemical bonding. The number of valence electrons is what primarily determines an element's chemical properties, and its group placement. Elements in the same group have the same number of valence electrons, leading to similar reactivity. For example, alkali metals in group 1 all have one valence electron, making them highly reactive. Beyond individual elements, the periodic table reveals fascinating patterns known as periodic trends. These are predictable changes in elemental properties as you move across periods or down groups. Two key trends we'll visualize are atomic radius and electronegativity. Let's look at atomic radius. As you move from left to right across a period, the atomic radius generally decreases. This is because the increasing number of protons pulls the electrons closer to the nucleus. However, as you move down a group, the atomic radius increases because new electron shells are added, making the atom larger. Now, consider electronegativity, which is an atom's ability to attract electrons in a chemical bond. Electronegativity generally increases as you move from left to right across a period as the nuclear charge increases. Conversely, it decreases as you move down a group, because the valence electrons are further from the nucleus and less attracted to it. By understanding electron configurations and visualizing these periodic trends, we gain a deeper appreciation for the periodic table's predictive power. It allows us to anticipate how elements will behave, form compounds, and react with each other, all from its elegant structure. To recap, we've explored the periodic table as an organized system, delved into the animations of electron configurations to understand reactivity, and visualized key periodic trends like atomic radius and electronegativity. These concepts are fundamental to chemistry. The periodic table is a living document of scientific discovery, constantly expanding our knowledge of the universe. Keep exploring, keep questioning, and continue to delve into the fascinating world of elements. Your journey into chemistry is just beginning. Thanks for watching. If you found this video helpful, be sure to check out mentivia.com for more educational content. There you'll find completely free e-learnings, videos, and articles designed to deepen your understanding across a wide range of topics. And if you'd like to keep learning with us, don't forget to subscribe to the channel. We've got plenty more coming your way.